speaker of the day will be Miss Nurul Asyikeen. She's a data scientist from Rio Tinto. She's a accountancy graduate with second major in corporate communication. She started her career in KPMG under the risk advisory department, where she spent 5 years analyzing risk and process effectiveness in day-to-day operations by combing through documents, financial accounts, as well as interviews. She actually took a leap of faith in career switch and took masters in data science and joined Rio Tinto. And in fact, in August, she hopes to actually further her doctorate in computer science. So without further ado, I invite Shikin to actually share with you a little bit more about data science.
All right, thank you, Vera. I'll start
Right.
sharing my screen and begin on, oops, 1 second, I clicked on the wrong thing. Right, here we go. So as Vera has already mentioned about my education and career journey, it's not really been straightforward. I started off as an accountancy graduate, and that's when I wanted to use my accountancy knowledge and join KPMG as the usual accountancy graduates do, or any other big four audit firms. And it was only after 5 years I decided to build up on my technical knowledge, and that really fell back to what exactly I've learned in KPMG through the business operations and knowing the processes and knowing how different industries work as well. Also using data in different settings helped me to frame my decision on what exactly to tackle next in my career journey. Uh, and I ruminated and looked back to my bachelor's degree, where I very much enjoyed management science. And there wasn't really a management science master's. So when I was looking through what was the course that was most related to management science, data science came up as the choice. And then there came the question of which university that I should be studying in. And at that point of time, and even now, SMU was the top in Asia and 11 in the rest of the world. Now it has slipped down to number 14. And afterward, I did not start off as a data scientist. When I graduated, I became a data analyst first. After 2 years of building up my technical skills in programming and also in machine learning in general, that's when I transitioned into data scientist role within the same department. And I feel that even though they have a breadth of knowledge of data science, really it's still quite important to be very good or having a niche area. And that's why I'm starting, hopefully, inshallah, in having a doctorate of engineering in SMU for computer science. So that's my education career journey, which is still continuing. And let's start off with what exactly is analytics, because I know people have heard this word a lot and not really sure what it means. And across the years, there's a lot of these buzzwords of what big data is, machine learning, AI. I'm not really sure how that really falls into the whole entire framework of analytics. So I'll start with why this is important for you, and then going next to what exactly do you do, knowing that it is important for you. So I'm sure in our day-to-day work life, there is some form of analytics that we're using, just that we're not aware that we're using it. So analytics is really just statistics. And when you scale up the use of statistics, and that's when you reach the point where it becomes data science and machine learning. So I'd like to fall back to the Gartner analytics maturity model that you see here, where they categorize it into 4 segments. Namely, the descriptive analytics, where it examines what happened. Then it moves on to diagnostic, where it looks like why exactly this happened. And then with all this knowledge, we then want to predict what would happen in the future. And with the knowledge of this, what can we do as a business to gain value from this knowledge, right? And there's different levels of value and difficulty. So as we move from left to right, the value to the business moves from hindsight to insight and finally to foresight. And of course, the difficulty will also increase. And business analysis would sit within the first two, descriptive and diagnostic. And that's where data science and machine learning is, where we scale up this analysis. And this is a fun way of look and understanding what machine learning is. In a nutshell, I would like to say that it's just statistics on steroids, because it's just merely using mathematical models and algorithms, and having the technology that we do, we scale it up in a fashion that is automated, whereby the model can react to the results in a feedback loop, and then it will able to give better results each time. So there will be the data set, which of course the more data the better, and there will be and this will be segmented into a testing data and training data. So we are feeding the algorithms, the data into the algorithms, and with this model that we built, we then test on how well the algorithm is working on the testing data. And this will be again a loop while we try to iteratively increase the accuracy of the model. And this is how my day-to-day life as a data scientist is. There's quite a lot of steps to it, and you can see the user is the most important person in the data science process, because the user would define the business problem that we would like to resolve using data science. And we come in knowing the workflow and the day-to-day operations and what they want to achieve out of it. We try to scope it into something that can be solved with data science, and how we can scale it up that it will be effective or useful to them. They will also inform us if there's any data sets that we can use. Of course, data is the most important thing. So if there's no data, there's really no data science model that we can build for them. We look into the data set that they provide and see whether it's useful, whether there could be more data that we should be relying on, and how we should be cleaning this data so that we can move forward. And from experience, when we get the data, it is not in a very nice looking format where all the fields are filled, all the information is correct. It's only when we do data exploration, go really deep diving into data, that we realize there are gaps in the data. And then we go back to the user to ask them about all these anomalies that we're seeing and how we can address these anomalies based on their user and business knowledge. And once we have sorted that out, we move on to engineering the features. So basically extracting what is most useful from it by some statistical analysis before we feed it into a model that is useful, that is applicable to that problem. And usually within a data science process, there'll be several models that we will build just to make sure that the model is we will choose the better performing model. And this would be an iterative loop. Once we have tested the model, we will then go back to the user and give him or her the results, and seeing whether he or she can value add to the results and how we can further improve the model. And finally, when the business user is satisfied with the model, that's when we start to deploy it. And yeah, so going back to a data science process, from end to end, 80% of time is really just spent on looking at data, engineering it, cleaning it, and making sure the model is able to pick up all these nuances from the data. And it will just go for an iterative loop. And really, just 50% of time is just cleansing and engineering for features over and over again until we can get a good prediction accuracy. And when it comes to the model deployment, that's when the user also comes in the picture, where the user will inform us how exactly does he want to ingest all this prediction on a daily basis. So it could be in many forms, where either a web application, a dashboard, or even a daily email. stating the key things that he wants to know every day before he can make any business decisions. And the data science teams and the kind of skill sets is shown in these two Venn diagrams. There are three key components of a data science team where you will need mathematical or statistical knowledge or knowledge of algorithms and how to use them in different situations. You need to know how to program and code and develop, right? And finally, you also need to know how to communicate all this information to the end user. Because as you can tell, algorithms are not very straightforward. Uh, and if we tell or we tell them exactly how the algorithm works, the user will not be able to digest the information. So we have to give them analogies, some type of bite size pieces that they can understand how this model works and how it's useful for them, and what are the value adding items from the model. So
Shikin,
the
I'm
three.
so sorry. I need to cut you a little bit. I can
Sure.
maybe 2 more minutes before we end your part.
Oh, right.
Kesian.
Yeah, so I'll fast forward.
Yeah.
Right, so the next Venn diagram will just be showing the four main components of skill sets. And then when you look at the center, that's where the data scientist really sits, well, it's the perfect one. So this is just a very quick look at how broad the machine learning sector is. And I'll just move on to the kind of data types that we do look into. So there's algorithmic, spatial even. And if you want to jumpstart your journey into as becoming a data scientist, there are some things that you need to know in terms of coding. So there will be Python, where these are some of the key libraries that you look into, such as Keras, TensorFlow, that will help you in machine learning. And the next one will be R, and this also some of the key libraries that will be useful for you. And another thing to note will be how much there's materials to learn data science. There's Udacity, Coursera, and Udemy. I'm personally using DataCamp as a form, making sure that I am up to date in my programming language. And that brings me to the end of my presentation.